There's a moment in every high-stakes engineering project where all the promises, all the timelines, all the confidence converges into a single question. Does it actually work? For Tesla, that moment is right now, April. And what makes this different from every other Elon Musk deadline is that this time, 3 separate technological bets, one supposedly impossible on its own, all supposed to deliver at exactly the same time. The Cybercab is entering production in about 8 weeks. The Optimus humanoid robot is supposedly ready for million-unit per year manufacturing, and the 4680 battery. The thing that spent years being called a complete failure by industry experts is suddenly being described as a breakthrough. But here's what almost no one is talking about. None of these technologies actually work yet, not at scale, not reliably, not in the way Musk has been describing them. And the deeper you look into what's actually happening inside Tesla's factories, the testing facilities in Alaska, and the supply chain negotiations with China, the more you realize that this year isn't just another chapter of incremental progress, it's the year where everything either works or the entire vision collapses. And the clock is already running. Let's start with what Elon Musk said publicly during his conversation with John Collison and Dorkish. He didn't hedge. He didn't use maybes or probablys. He said Optimus 3 is the right version of the robot to produce maybe something on the order of 1 million units a year. 1 million units. That's not a prototype number. That's not a pilot program. That's mass production language. The kind of language you use when the technology is proven, when the supply chain is locked in, when the manufacturing process has been debugged and stress-tested across thousands of production cycles. But Optimus has never been deployed outside of controlled environments. It's never worked a full shift in a real factory alongside human workers. It's never handled the kind of variability and chaos that exists in actual industrial settings. And yet Musk is talking about scaling to 1 million units a year as if the hard part is already done. Now, you might think this is just classic Elon optimism, the kind of aspirational timeline that gets walked back 6 months later. But here's the thing. He's not talking about Optimus in isolation. He's describing it as part of an integrated ecosystem where the robot is the hands and feet. And Grok, the AI system developed by XAI, is the brain. The robots don't think independently. They execute tasks assigned by a centralized intelligence that coordinates thousands of units simultaneously, optimizing workflows, reallocating resources, adjusting priorities in real time. If a new factory needs to be built, Grok analyzes the goal, breaks it into thousands of tasks, and assigns each one to specific Optimus units. One group handles material transport, another assembles structures, another inspects and maintains equipment. It's a vision of manufacturing that doesn't exist anywhere in the world right now, and Tesla is betting that it will exist at scale within the next 12 months. But here's where the story starts to get uncomfortable, because Optimus isn't the only thing that has to work. The Cybercab, Tesla's fully autonomous robotaxi with no steering wheel and no pedals, is supposed to enter production in April. That's not a vague future target. That's 8 weeks from now. And just a few weeks ago, a field technician leaked a video showing something that wasn't supposed to be there. A physical charging port, hidden beneath an electrically actuated panel near the rear taillight. The Cybercab was supposed to rely entirely on wireless inductive charging. Elon Musk stood on stage at the Warner Brothers Discovery Studios back in October and painted a vision of a vehicle that never needs to be plugged in. It just backs up, parks over a charging pad, and charges. No human intervention. No cables. The ultimate expression of full autonomy. But now, prototypes are being spotted plugged directly into V4 supercharger stalls. And the question everyone started asking immediately was, did Elon lie? Was the wireless charging story just marketing? Or is something else going on? The answer, as it turns out, is more complicated than either extreme. Wireless charging works. Tesla has demonstrated it in controlled environments. But high-power wireless charging, the kind that can recharge a large battery pack quickly enough to keep a robotaxi fleet economically viable, is an extremely difficult thermal management problem. When you transfer current via a magnetic field between two coils, a significant amount of energy is lost as heat. The more power you push through the system, the hotter it gets. And if the cooling system can't handle that heat, the charging speed has to slow down. which defeats the entire purpose. So Tesla made a decision. They kept the wireless charging system for convenience, for topping off the battery during short passenger wait times, but they added a physical port as a fallback. Because if you're trying to bring a vehicle into commercial production in April, you can't afford to bet everything on a technology that might not be ready. The wired port is the plan B. The safety net, the thing that ensures the Cybercab can operate reliably even if the wireless system isn't perfect yet. And this is where the pattern starts to emerge. Because the 4680 battery, the third piece of this technological puzzle, has the exact same story. It was supposed to be ready years ago. Elon Musk unveiled it at Battery Day in September 2020, calling it the biggest leap forward in lithium-ion battery technology ever. The tables' design would reduce heat and increase power output. The dry electrode process would eliminate toxic solvents, cut factory footprint by 90%, and slash production costs in half. It was going to enable a $25,000 Tesla. It was going to make electric vehicles cheaper than gas cars. It was the foundation of everything, except it didn't work. Not at first, not for years. From 2020 to 2023. Tesla could only produce 4,680 cells using a hybrid process, dry anode, wet cathode, which meant they still needed the massive drying ovens, the toxic solvent handling systems, all the infrastructure they were supposed to eliminate. The cost savings evaporated. The energy density was lower than the older 2,170 cells. Production yields were terrible. Materials cracked. Adhesion failed. Defect rates were high. Elon Musk himself admitted that scaling the dry electrode technology was much harder than expected, that even a tiny deviation could break the entire production line. And because of that, the 4680 battery spent 2 years being used almost exclusively in the Cybertruck. Not because the Cybertruck was the best application for it, but because the Cybertruck was the only vehicle that could absorb the risk. It had a new architecture, a high price point, enough margin to cover the cost of an unoptimized battery, and production volumes were low enough that if something went wrong, it wouldn't cascade across Tesla's entire lineup. But using the Cybertruck as a testing ground created a perception problem. People started to believe the 4680 was a failure, that Tesla had bet on the wrong technology, that the company was stuck in what Elon himself calls production hell, unable to escape the gap between what works in a lab and what works at scale. And then, quietly, something changed. In Tesla's Q4 update and fiscal year 2025 report, the company stated that it is now producing 4,680 battery cells with both electrodes, manufactured using the dry electrode process, both electrodes, anode, and cathode. The thing that was supposed to be impossible to scale. The thing that experts said would never work in mass production. Tesla solved it. Elon Musk confirmed it on X, writing that making the dry electrode process work at scale was a major breakthrough in lithium battery production. Technology, and incredibly difficult. He congratulated the engineering, production, and supply chain teams. Bone Eggleston, Tesla's vice president of 4,680 batteries, wrote that both electrodes now use our dry process. And just like that, the entire cost structure flipped. Without toxic solvents, Tesla no longer needs energy-hungry drying ovens that take up massive amounts of factory space. Internal estimates suggest factory floor space can be reduced by up to 90%, while energy consumption per battery cell drops significantly. For the first time, the 4680 battery is actually cheaper than the 2170 on a per kilowatt-hour basis when produced in the United States, not in theory, in practice, right now. But here's the part that matters most, and the part that almost no one is paying attention to. This breakthrough needs a battery that can charge fast, because it had to, and cost less than what's available on the global market. Work. Optimus needs a power source that's energy-dense, lightweight, and reliable enough to run for hours without overheating. And both of them need to be produced domestically in the United States, using a supply chain that doesn't depend on China. Which brings us to the geopolitical layer of this story. The part that nobody talks about, but that underlies every decision Tesla is making right now. According to Morgan Stanley, if Tesla were to completely remove Chinese components from the Optimus supply chain, the production cost per robot would jump from around $46,000 to as high as $131,000. That's not a marginal increase. That's a 3x cost explosion. And it's not because Chinese manufacturers are doing anything particularly advanced. It's because China has spent the last 2 decades building a manufacturing ecosystem that no other country can match. 63% of the global humanoid robot component supply chain is in China. Actuators, sensors, thermal management systems, all of it. Tesla has established partnerships with hundreds of Chinese suppliers, many of which are involved from the early stages of R&D and design. Companies like Ningbo Tuopu for actuators, Sanhua for thermal management, Eversun for sensors. These aren't just vendors, they're co-developers. And Tesla's goal of driving the price of Optimus down to around $20,000 makes not relying on China, at least in the short term, almost impossible. But at the same time, Tesla is preparing for a world where those supply chains might not be available, where tariffs, export restrictions, or political tensions make Chinese components too expensive or too risky to depend on. And that's why the 4680 battery is back in the Model Y, not because it's the cheapest option globally, but because it's the cheapest option that Tesla controls when you add in tariffs, domestic incentives, and supply chain risk. The 4680 becomes not just competitive, but strategic. It's the battery you produce yourself when you can't rely on anyone else. And this same logic applies to Optimus, to the Cybercab, to every piece of Tesla's future. The company is building redundancy into every layer of the stack. Wireless charging with a wired fallback, domestic battery production with Chinese components as a bridge. AI systems that inherit from self-driving but extend into robotics. Everything is interconnected, and everything has to work at the same time. Because if one piece fails, the entire structure collapses. Elon Musk has admitted this openly. He said that for both Cybercab and Optimus, almost everything is new, so initial production will be extremely slow. But eventually, he added, it will be unbelievably fast. Tesla will be capable of producing a Cybercab in under 10 seconds at Giga Texas. That's the S-curve he keeps talking about. Slow and painful at the beginning, then exponential acceleration once the bottlenecks are resolved. But the S-curve only works if you survive the bottom. And right now, Tesla is at the bottom. Let's talk about what's actually happening in Alaska right now, because this is where the theoretical meets the real. In the early days of this year, Tesla Cybercab prototypes were officially transported to some of the most extreme winter conditions imaginable. Heavy snowfall, dense fog, roads covered in black ice that completely obscure lane markings. The kind of environment where even human drivers struggle. And Tesla is testing a vehicle with no steering wheel, no pedals, and no ability for a passenger to take over if something goes wrong. The focus is on pushing the Tesla vision system to its limits. Because unlike other autonomous vehicle companies that use LiDAR, radar, and a dozen other sensors, Tesla relies almost entirely on cameras, vision only, the same way humans drive. And in winter conditions, that's an enormous challenge. Cameras can't see through snow. They can't penetrate fog. They struggle with glare, with dirt, with road salt buildup, which is why these test vehicles are equipped with a dedicated rear camera washer system, ensuring clear visibility even when the roads are a mess. But cleaning the cameras is only part of the problem. The real challenge is localization. When lane markings are buried under snow and the GPS signal is weak or unreliable, how does the vehicle know where it is? How does it distinguish between the road and the shoulder? How does it detect black ice, which is invisible even to human eyes? These are the questions Tesla has to answer before the Cybercab can be deployed in northern climates, and they have 8 weeks to do it. But Alaska isn't just about autonomous driving. It's also a testing ground for the wireless charging system, because in sub-zero temperatures, inductive power transfer efficiency can be affected by thick layers of ice accumulating beneath the vehicle. Tesla has to ensure that charging efficiency remains above 90% even when the charging pad is covered in snow, ice, and road salt. And if it doesn't, that's when the wired charging port becomes essential. The fallback that keeps the fleet operational when the ideal solution isn't quite ready. And this is the part of the story where you start to realize that Tesla isn't just building vehicles. They're building an entire operational framework. A system where vehicles, charging infrastructure, AI coordination, and fleet management all have to work together seamlessly. Because a robotaxi isn't useful if it can't charge reliably. It's not useful if it can't navigate in bad weather. It's not useful if it breaks down after 6 months, because the actuators overheat or the battery degrades faster than expected. Every piece has to be bulletproof. And none of them are. Not yet. Elon Musk has said that the Cybercab will use unboxed manufacturing, a completely different production process compared to Tesla's other vehicles. Instead of moving linearly through hundreds of stations like the Model Y, the Cybercab is divided into large modules that are assembled in parallel. The front megacasting, the rear megacasting, the structural battery pack, a fully assembled interior, pre-painted exterior plastic panels. These modules are built independently in separate areas, then rapidly joined together in the final assembly zone using only about 25 stations instead of 150 to 200. It's faster, it's more efficient, it requires less factory space, but it also requires everything to be perfect before assembly even begins. Because once the modules are joined, there's no going back. You can't fix a defect in the battery pack after it's been integrated into the structure. You can't adjust the interior after the megacastings are bolted together. The tolerances have to be tight. The quality has to be flawless. And Tesla has never done this before. Which brings us back to the 4680 battery. Because the structural battery pack, the thing that holds the entire Cybercab together, is built around 4,680 cells. And those cells have to be produced at scale with consistent quality, at a cost that makes the economics of the robo-taxi business model actually work. Elon Musk has promised fares cheaper than a bus ticket. To achieve that, the Cybercab needs to stay on the road as much as possible. It needs to charge fast. It needs to last hundreds of thousands of miles without major maintenance. And all of that depends on the battery. Tesla has confirmed that it completed the dry electrode process for both electrodes, anode and cathode, in its 4,680 cells. This is a major breakthrough. But completing the process and scaling it to millions of cells per year are two very different things. The dry cathode has always been the most difficult part. It requires precise control over particle size, pressure, temperature, and humidity. Even a tiny deviation can cause cracking, reduced energy density, or higher costs. Elon Musk described it as incredibly difficult to scale for mass production. And he's right. This is the kind of manufacturing challenge that can take years to fully resolve. But Tesla doesn't have years. They have weeks. The Cybercab is supposed to enter production in April. And if the 4,680 battery isn't ready, if the yields are too low or the costs are too high, the entire timeline collapses. Now, let's layer in the competitive context. Because while Tesla is fighting its way through production hell, the rest of the world isn't standing still. In China, humanoid robots like Unitree are being sold for as little as $6,000 to $13,000. That's a fraction of what Tesla expects to charge for Optimus. And while Elon Musk argues that those robots are smaller, less intelligent, less dexterous, and not designed to carry heavy loads for long periods, the price difference is impossible to ignore. If a factory can buy 10 Unitree robots for the price of one Optimus, does it really matter if the Optimus is better? Maybe, maybe not. It depends on what the robots are being used for. And this is where Elon's strategy becomes clearer. He's not trying to compete on price in the short term. He's trying to build a robot that can actually do useful work in unstructured environments. A robot with intelligence and dexterity that match or exceed human levels. A robot that can operate for long periods without overheating, without breaking down, without needing constant human supervision. That's a much harder problem to solve than building a cheap robot that can walk around and wave its arms. But it's also the problem that, if solved, unlocks the real value. Because if Optimus can genuinely replace human labor in factories, let's talk about AI5 and eventually home, because this is the piece that ties everything together. Elon Musk, together with Tesla's supply chain partners in South Korea, has outlined an ambitious vision for AI5. The next generation chip that's widely regarded as the key to unlocking Tesla's future. Far more than a simple upgrade, AI5 represents a shift from a conventional automotive processor to a compact supercomputer integrated directly into the vehicle. The biggest breakthrough of AI5 lies in its staggering compute density. According to Elon Musk, a single AI5 system on chip delivers performance comparable to an NVIDIA H100 GPU, a $30,000 data center monster that consumes up to 700 watts of power. When two AI5 chips are paired together, their combined performance could even rival NVIDIA's latest Blackwell B100B200 lineup. Imagine this: Tesla has effectively compressed the power of a massive data center server into a compact device tucked behind the glove box, running off the car's low-voltage battery and at a fraction of the production cost. This means that every future Tesla vehicle could possess artificial intelligence on par with the most powerful supercomputers in the world today. Why does Tesla need such enormous computing power? The answer lies in FSD, unsupervised, and the humanoid robot Optimus. While the current AI for chip is already running FSD version 14 impressively, Elon Musk has acknowledged that achieving absolute safety and handling complex traffic scenarios in a truly human-like manner without any driver intervention requires an exponential increase in compute. AI5 is the solution that makes this vision achievable. It provides ample computational headroom to run deeper, faster neural networks, enabling the vehicle to react instantly to its surroundings. On the supply side, Samsung's factory in Taylor, Texas is set to begin equipment testing next month in preparation for mass production of AI5 in the second half of this year. Although AI4 will remain the primary platform for the Cybercab launching in April, AI5 is expected to gradually take over as the main architecture starting in 2027, notably as the design of AI5 nears completion. Tesla is shifting its focus toward Dojo 3. If AI5 is the brain that enables vehicles to reason and act on the streets, then Dojo is the massive server system used to train those brains. The combination of AI5 in the vehicle and Dojo in the data center creates a closed end-to-end ecosystem in which Tesla maintains full control over everything from hardware to software. And this is crucial because it means Tesla doesn't depend on NVIDIA, doesn't depend on external chip makers, doesn't depend on anyone else's roadmap or priorities. They control the entire stack. But here's the part that matters most. AI5 isn't just for cars. It's for Optimus. The same chip that will enable unsupervised full self-driving in the Cybercab will also power the humanoid robots working in Tesla's factories, and this is where the vision starts to become clear. Tesla isn't building cars and robots as separate products. They're building a unified AI platform that runs on the same chips, uses the same neural networks, learns from the same data. A car is just a robot on wheels. A robot is just a car with arms and legs. The underlying technology is identical. And once you understand that, you understand why everything has to converge this year. Because if AI5 isn't ready, FSD unsupervised doesn't work. If FSD unsupervised doesn't work, the Cybercab can't operate without a driver. If the Cybercab can't operate without a driver, the robotaxi business model collapses. And if the robotaxi business model collapses, Tesla's valuation, which is based largely on the assumption that the company will transition from selling hardware to delivering ultra-high-margin software services, falls apart. Now, let's talk about the hands, because this is the detail that reveals how hard this problem actually is. Elon Musk has repeatedly emphasized that the hands are the hardest component of any humanoid robot. According to him, from an electromechanical standpoint, the human hand is an almost absurd structure, dozens of degrees of freedom, incredibly fine force control that humans use effortlessly without even thinking about it. He said bluntly that he hasn't seen any robot demo with a truly good hand, one that has the full range of degrees of freedom comparable to a human hand, and he claims that Optimus now has that. To reach this level, Tesla had to design everything in-house: the motors, the gearboxes, the sensors, the control systems, simply because there is no existing market that offers a real full capability robotic hand. This is not an off-the-shelf component. This is not something Tesla can source from a supplier. It's custom-built from first principles physics, and it has to work reliably, thousands of times per day, for years, without failing. Because if the hands break, the robot is useless. You can't pick up parts. You can't assemble structures. You can't perform delicate tasks. The entire value proposition disappears. And this is the manufacturing challenge that Elon keeps coming back to. Optimus production will follow a stretched-out S-curve. Very slow, even painful at the beginning, then accelerating exponentially once the manufacturing bottlenecks are resolved. The hands are one of those bottlenecks. The actuators are another. The sensors, the control systems, the power electronics, all of it. Every component is custom designed. Every component has to be manufactured at scale. And none of it exists yet. Not in the volumes Tesla needs. This is why Elon has been very clear that the early stage of Optimus won't focus on complex household tasks. Instead, it will handle simple, repetitive jobs that can run 24/7, and the first deployment will be in Tesla's own factories, where the environments are highly structured, tasks are standardized, and efficiency can be measured directly through output. This is where Optimus can deliver value the fastest and also collect the best data. In a gigafactory, Optimus Gen 3 could take on about 10 to 20% of the workload currently done by humans. But here's the key part. Tesla has no intention of reducing its workforce. The total number of human workers will actually increase because output per person will increase dramatically thanks to robotic support. In the past, an engineer or a worker could only supervise a single production line. But in the future, they'll be able to oversee multiple Optimus robots at the same time. This is how Elon views the relationship between humans and robots. Not as total replacement, but as a way to amplify human capabilities. It's a compelling vision, but it only works if the robots actually work. And right now, they don't. Not at the scale Elon is describing. The largest deployment of Optimus robots is still measured in dozens, not hundreds or thousands. And even those robots are being closely supervised, still being debugged, still proving that they can handle basic tasks before anyone trusts them with anything more complex. So when Elon says that Optimus 3 is ready for mass production, what he really means is that the design is ready, the engineering is ready, the manufacturing plan is ready, but the execution, the part where you actually build 1 million robots per year, is still ahead. And that's the hard part. Let's go back to the Cybercab for a moment, because there's a detail that's easy to miss, but that reveals a lot about how Tesla is thinking. Lars Moravi, Tesla's Vice President of Vehicle Engineering, recently pointed out that more than 90% of car trips today carry 2 passengers or fewer. He noted that this reality has directly influenced the design of the Cybercab. Tesla has no intention of forcing the Cybercab to handle every possible passenger scenario. The Cybercab will cover the majority of trips within the robotaxi network. Trips requiring 3 or 4 seats will be handled by the Model Y robotaxi. For higher-end use cases or larger families, the extended wheelbase Model YL can carry 5 or 6 passengers, although it hasn't launched in North America yet. And for even larger groups or commercial transport, Tesla has introduced the Robovan, which can carry more than 10 people. It's clear that instead of pushing a single vehicle to meet every need, Tesla's approach reflects how transportation already works today. Different vehicles are used for different purposes, all unified under a single self-driving software stack and fleet management platform. This is smart, it's pragmatic. But it also reveals that Tesla is optimizing for the most common use case first, then filling in the gaps with other vehicles. The Cybercab doesn't have to be perfect. It just has to be good enough for 90% of trips. And that's achievable. But achieving it in 8 weeks with a vehicle that uses a completely new manufacturing process, a completely new battery architecture, and a completely new autonomous driving validation framework is a different story.